Good morning. For today's experiment in Physics Lab 1, Phase 212, we have experiment number 5 about the buoyancy force of Principle of Archimedes. In the experiment apparatus, as experiment apparatus, we have a beaker, a graduated beaker. We have a dynamometer, in order to measure the force applied on a solid and hollow cylinder. We have the support, a bottle of water, and different weights of different values. So from 50 gram, 100 gram, 1 gram, and so on. Here we have a solid cylinder with 3 marks. So the first mark for the solid cylinder, the second mark, the third mark. And here we have a hollow cylinder. So the main objective of this experiment is to prove the principle of Archimedes, which states that the buoyancy force or the buoyant force applied on a immersed solid cylinder, for example, or an immersed object in water, the magnitude of this buoyant force is equal to the magnitude or is equal to the weight of the displaced water. So this is the objective of the experiment, and in order to do it, we have to attach the solid cylinder to the hollow cylinder. So the solid cylinder with the hollow cylinder, and then to the dynamometer. When the hollow and the solid cylinder are suspended in air, now the dynamometer gives us the gravitational force, since they are suspended in air. So the gravitational force, as we can see from the dynamometer, if we read the value, it's almost 2.1 Newton. When we will immerse the solid cylinder in water, we'll see that this value of force will be less than 2.1, since we have a upward buoyant force, and the dynamometer will give us the resultant force, which will be labeled as F prime. So F prime is the resultant force between the gravitational force and the buoyant force. Now we have to fill or to put about 220 milliliter of water in the beaker. So 220 milliliter of water. What we have to do is to immerse the solid cylinder. First, we immerse the solid cylinder to the first mark, then to the second mark, to the third mark, and completely immersed. At each time, we have to measure the new volume of water. So as initial volume of water, we have 220 milliliter. So at each time, we have to measure the new volume of water, so we can find the displaced water, the volume of the displaced water, and F prime from the dynamometer. So just to turn the graduation. Okay. So we immerse the solid cylinder till the first mark. So the first mark is at the surface of water. What we have to do is to measure the final volume and the F prime from the dynamometer. The final volume is 220, 230, about 240 milliliter. And F prime is 1.9 Newton. So F prime become less than Fg, which was 2.1 Newton when the solid cylinder is suspended in air. Now we move the dynamometer and we immerse the solid cylinder till the second mark. Same, we have to measure the final volume the final volume is 255 milliliter, and F prime is 1.7 Newton. Same, we immerse till the third mark. The final volume is about 270 milliliter, and F prime is almost 1.5 or 1.6 Newton. Now we completely immerse the solid cylinder. So the solid cylinder is completely immersed. The final volume is 290 milliliter, and the final and F prime 1.4 Newton. The solid cylinder is again suspended in air. So now we fill the value for an empty hollow cylinder, and we got the values for F prime and V final. By calculation, we can find FB using the equation Fg minus F prime, and same FB using the equation of rho times V immersed. V immersed is V final minus V initial. So for the first mark, it's 240 milliliter minus 220 milliliter. For the second mark, it's 255 minus 220. So we can find the value of FB. This set is for an empty hollow cylinder. Now we will fill the hollow cylinder with water. So we change the weight of the system hollow and solid cylinder, and we will see what we will get as a buoyant force, or FB. So we will fill the hollow cylinder with water, a random amount of water. And now we will have a new Fg, new gravitational force, since we have the mass of water, which is 2.6 Newton. So Fg, the gravitational force now, is 2.6 Newton. The same steps, we will immerse the solid cylinder till the first mark. The new volume of water is about 240 milliliter or 238 milliliter. The new F prime is 2.4 or 2.5 Newton. We immerse till the second mark. The new volume of water is 253, let's say 253 milliliter, and F prime is 2.3 Newton. Till the third mark. The volume of water is 270 milliliter, and F prime is 2.1 Newton. 2.1, yes. 2.1 Newton, and finally the solid cylinder is completely immersed. The final volume of water is 290 milliliter, and as F prime we have 1.9 Newton. Again, so now we did the experiment. with a empty hollow cylinder and a hollow cylinder filled with water. If we compare the results of FB from both calculations, we see that FB is almost the same when the hollow cylinder was empty and when the hollow cylinder was filled in water. That proves the state of Archimedes' principle that the buoyant force, or FB, is equivalent when we have the same object immersed in water. So here we are immersing in water the solid cylinder till the first mark. We are immersing the solid cylinder till the first mark, the second mark, the third mark, and completely immersed. Whatever the weight of the hollow cylinder was, but the part immersed in water was the same. So we have the same volume immersed, V final minus V initial, and then we have the same buoyancy force. What we have to do to complete the experiment is to put in the hollow cylinder a slot of 20 gram of 20 gram. We have to put 20 gram, a mass of 20 gram in the hollow cylinder, 50 gram in the first part, and 100 gram in the final step. So we have the hollow cylinder, 20 gram, 50 gram, and 100 gram, and we repeat the experiment. What we will see is that only Fg change, since we are changing the masses in the hollow cylinder, and F prime will change correspondingly, but Fb will remain the same, and V immersed will remain the same. So as a conclusion, the buoyancy force or the state of Archimedes' principle was proved. The buoyant force was the same, whatever the mass in the hollow cylinder was, and Fb was relative to the volume of immersed object, or the volume immersed, the displacement volume of water, and Fb was equal to the weight of the displaced water. That's everything about this experiment. Only I have to mention something, that here we have Fb in the equation of Fb equal the density of water, or density of liquid, in our case it was water, times V immersed times the gravitational force, gravitational acceleration. The density of water is 1 kilogram per liter, or 1 gram per milliliter. We have to use the same unit for the density of water and V immersed. So if the density of water was in liter, we have to use V immersed in liter. If the density in milliliter, V immersed should be in milliliter as well. So, and here rho times V immersed will give us the mass of the displaced water, and it is times G, so the weight of the displaced water. Thank you, and see you next week, or see you next time in experiment number 6.